So today's topic is shared memory. So in interprocess communication, using shared memory, it requires a communicating process to establish a region of shared memory, and the shared memory basically resides in the address space of the process, creating the shared memory segment. So in this figure, we can see that process A is trying to communicate or pass a message to process B via a shared memory. So in the process who is initiating the communication is responsible of creating an address space for the shared memory segment. The other process that wish to communicate using this shared memory segment must attach it to their address space. That is, here the process B has to attach to the address space of the shared memory segment so that it can read the messages that is sent by process A. So normally the OS tries to prevent one process from accessing another process memory. So in the normal case, process A cannot access the memory of process B, and likewise process B cannot access the memory of process A. But if shared memory system has to be implemented, then two or more processes must agree to remove this restriction. That is, if you want to use the shared memory, or if you want to pass a message by shared memory, the restriction of the operating system has to be removed. Okay, then only the shared memory communication can be established. Now a best example for the shared memory system illustration is producer consumer problem. So here we have two processes. One is a producer process and one is a consumer process. A producer process produces some information and that will be consumed by the consumer process. For example, a compiler may produce an assembly code which is consumed by an assembler. So in this case, the compiler will be the producer and the assembler will be the consumer. And the problem is that we have to keep the consumer and the producer process working concurrently. So how we can make them work concurrently? So one such solution for producer consumer problem is using the shared memory. So to allow producer and consumer process to run concurrently, we must have we make use of a buffer of items or a buffer that can be filled by the producer and emptied by a consumer. So this buffer will reside in the shared memory region, or the region of the memory that is shared by the producer and the consumer process. A producer can produce one item while the consumer is consuming another item. Okay, so producer keep on producing the item and the consumer can consume whatever is produced by the producer from this shared memory region. And this buffer will reside in the shared memory that is shared by the producer and consumer process. Again, the producer and the consumer must be synchronized so that the consumer does not try to consume an item that has not been produced yet by the producer. And here we told that they make use of a buffer, okay, which resides in the shared memory, and this buffer can be of two types. One is the unbounded buffer and the bounded buffer. So coming to unbounded buffer means it places no practical limit on the size of the buffer. That is, the buffer is of unlimited size. So the producer can keep on producing the items, okay, and the buffer won't get full at any time. Okay, so the producer keep on producing, and the consumer may have to wait for new. Suppose the consumer may have to wait for new items to arrive into the buffer. Okay, that is the case when the buffer is empty, then the consumer will have to wait for an item to come into the this buffer. Okay, but the producer can always produce new items. So the producer can keep on producing the items, whereas the consumer may have to wait initially when the buffer is empty. Okay. Again, the second type of buffer is the bounded buffer. So it assumes a fixed buffer size. That is, the buffer has some size limit. Only n number of messages can be kept in the buffer at a time. Okay. So the producer must wait for the buffer when the buffer is full. It has to wait to produce another item. Suppose the capacity of the buffer is 5, then if it is full, if there are 5 messages in it, then the producer process has to wait until a consumer process consumed it and there is a space for another message in the buffer. So there is a size limit in that.